Have you ever wondered how to create an interface in C++ without using virtual functions? It sounds tricky, but it's possible. Today, we're diving into a unique approach that leverages static assertions to define interfaces. I totally get it. Many developers face the challenge of implementing interfaces in C++ without the overhead of virtual functions. You're not alone in this quest for efficiency and clarity in your code. Here's the specific question we're addressing today. One user asked, how can we declare an interface in C++ without using virtual functions? They shared a solution involving type traits and static assertions. Sound interesting? Let's explore this together. So what does this approach entail? By using type traits, we can check if a class implements specific member functions at compile time. This allows us to enforce interface contracts without the need for virtual functions. And stick around. At the end of this video, I'll share some pros and cons of this method, along with potential improvements to the code. You won't want to miss it. To declare an interface in C++ without using virtual functions, the user can utilize type traits. This allows checking if a class implements specific member functions at compile time. The user can define a type trait called hasFoo. This trait checks if a class has a member function named foo that returns a Boolean value. Next, the user should create a class called interface. This class will use static assertions to ensure that any derived class implements the required member functions. For the implementation of the interface, the user can create a class called implementation. This class must define the member functions foo and bar to satisfy the interface requirements. Finally, the user can consider the pros and cons of this approach. The main advantage is compile time checking of interface compliance, while a potential downside is the complexity of the code. Fun fact, did you know that C++ was originally designed for system programming? Its flexibility allows for creative solutions like this one, proving that sometimes thinking outside the box pays off. Now, let's look at the answers provided by other users. Now, let's discuss the pros and cons of this approach. On the plus side, it avoids the overhead of virtual functions and can lead to better performance. However, it can also make the code harder to read for those unfamiliar with type traits. As for improvements, consider adding more descriptive error messages in your static assertions. This can help developers quickly understand what went wrong if they forget to implement a required function. An alternative approach to creating an interface in C++ without virtual functions is using the curiously recurring template pattern, or CRTP. In this method, you define a templated base class that forwards method calls to the derived class. This allows for static polymorphism while maintaining a structure similar to runtime polymorphism. This approach has several advantages. It resembles regular runtime polymorphism, provides clearer error messages, and allows the compiler to inline all code, eliminating overhead. Let's take a look at an answer from another user. This user suggests implementing concepts light in C++. They mention that you can use static assertions to express interface requirements, similar to the static assert method discussed earlier. They provide an example of a class template called sortable, which requires users to implement specific methods. To enforce this, users can utilize sortable in their class declarations. Here's a quick takeaway. Using static assertions for interface enforcement can lead to cleaner and more efficient code. Just remember to keep your error messages clear. And that's a wrap. You've learned how to create an interface in C++ without virtual functions, along with its pros and cons. If you found this video helpful, please subscribe for more coding tips and tricks.